Hello and welcome to our YouTube channel, Quick Solvers. Here I want to find the limit of f of x where x approaches 1 and f of x is defined like this, okay? And well, here this is telling me that the limit of f of x when x approaches 1 is not 0. And this is very important because it would help us to solve this problem without knowing a and b. So let's see how can we solve this. If I replace x by 1 because I'm trying to find the limit of the function when x approaches 1, then we would have f of 1 equals b times 2 minus, well, the third root of 1 is 1, okay? And then we have minus b here, and in denominator we have a times 1 plus b. Well, we know that this equals 1, so what we have here is b times 1, and b times 1 is b. So in numerator we have b minus b, which is 0, and in denominator we have a plus b. So the limit of f of x when x approaches 1 is 0 over a plus b, and we know this cannot be 0. And this is a bit strange, isn't it? Because we have 0 here in numerator, and we know when we have 0 in numerator, then the whole expression equals 0, but not in this case. And that happens only when the denominator is also 0. Then we would have 0 over 0, and we know this not equal to 0. Okay, so this is very important. And that's actually what we can get from this. So this is telling me that since the limit of f of x when x approaches 1 is not 0, then this 0 over a plus b cannot be 0, and that means a plus b should be 0, because that's the only case making 0 over a plus b not equal to 0. And when a plus b equals 0, I can conclude that a equals minus b. That means wherever I have a, I can replace that by minus b, or wherever I have b, I can replace that by minus a. Okay, that helps me to rewrite the whole function. Okay, so let's see what we get from this. Okay, so knowing that a equals minus b, then I can say f of x equals b times 2 minus third root of x minus b over minus b times x plus b. Okay, and from here I can factorize b, then I can write f of x equals b times square root of 2 minus third root of x minus 1 over b times minus x plus 1, or I would write it as 1 minus x. Okay, and well, this and this cancel out each other, and what is left is f of x equals square root of 2 minus third root of x minus 1 over 1 minus x. And we're actually trying to find the limit of this function where x approaches 1. So let's see how can we solve this now. Let me write down f of x here first. We saw that f of x equals square root of 2 minus third root of x minus 1 divided by 1 minus x. And if we calculate the limit of f of x where x approaches 1, this gives us 0 over 0. Okay, and we know that this answer is not accepted. This is an indeterminate form, and to find the actual limit of f of x where x approaches 1, one solution is to apply Hospital rule. What does Hospital rule says? It says to find this limit, you can calculate the differentiation of numerator the differentiation of denominator and then replace x by 1, and then you'll find the limit of f of x. Okay, so let's see how can we find this. Well, differentiation of denominator is easy, 1 minus x. Its differentiation is minus 1. So we don't have much to do here, but for numerator, that's a bit of work. We have square root of 2 minus third root of x minus 1, and we want to find differentiation of this respect to x. Well, we can quickly say that the differentiation of minus 1 is 0, so I can remove that. Okay. And generally, when we have something like square root of u, its differentiation equals, or let me show that by this prime. Its differentiation equals u prime, the differentiation of u, divided by 2 times the square root of u. So if I apply that rule here, so bear this in mind, this rule. If I apply the rule here, maybe I can just simply use the prime symbol for differentiation. Then this would be equal to differentiation of 2 minus third root of x divided by 2 times square root of 2 minus third root of x. Okay. And now it's time to calculate the differentiation of this. For 2, it's 0, so I can just ignore this. And then we have minus third root of x. Again, minus third root of x. Applying the rule that I used here, this differentiation of this equals differentiation of x, which is 1, divided by, well, maybe it's better to, maybe it's more understandable if I write this as minus x to the power of 1 over 3. Why is that? Because when we have a square root of a to the power, the mth root of a to the power of n, we can write this as a to the power of n over m. Okay. By applying this, I can rewrite the third root of x as x to the power of 1 over 3. And now its differentiation equals minus 1 over 3 times x to the power of 1 over 3 minus 1. 1 over 3 minus 1 is minus 2 over 3. Okay? And that means this equals minus 1 over 3 times x to the power of minus 2 over 3 divided by 2 times the square root of 2 minus third root of x. Okay? And all this is just the differentiation of, all this expression here is the differentiation of the numerator here. And for denominator, we also need to calculate its differentiation, which is minus 1. So we have the differentiation of numerator divided by differentiation of denominator, and that's the Hospital rule. So that means I need to divide this by minus 1. And now it's time to replace x by 1 to find the limit of f of x where x approaches 1. So if I replace x by 1, here we have 1 and here we have 1. So what we get is minus 1 over 3 times 1 to the power of minus 2 over 3 divided by, I can multiply this minus 1 to this, minus 2 times square root of 2 minus third root of 1. Okay. This minus and minus, this cancel out each other. What is left is 1 over 3 times 1 to the power of whatever is just 1. And I can just ignore it, okay? 1 over 3 divided by, and here we have 2 times the square root of 2 minus third root of 1. Third root of 1 is just 1. 2 minus 1 is 1. 2 times the square root of 1 is 2. Then we have 2 here and in denominator. So 1 over 3 over 2 is 1 over 2 times 3, or 1 over 6. Then the limit of f of x, where x approaches 1, is not 0, it is 1 over 6.